I'm going to cover the Unit 1 related topics under computer architecture. First, I will explain about the block diagram of a functional computer. For example, there is an input unit which is having a communication with the CPU, central processing unit, and the results will be redirected to the another unit called output unit. And CPU can perform the read and write operation that can be communicated in the bidirectional communication with the memory unit. And inside the CPU, control unit, arithmetic logic unit, and one more important thing are called registers. So this is the functional block diagram of a computer. Our computer, we can imagine our computer into 4 blocks: input block, output block, memory block, and CPU block. In CPU, we catch the input from the input unit, and as part of the processing the inputs, it may read and write. It may perform the read operation and write operation. It's like if your CPU dumps something to here, it is called write operation, and it is trying to read some information towards the observation. That means CPU reads some information from the memory. So it is read operation. Both are clear followed is a bidirectional. CPU is having a bidirectional communication with the memory. Now, so CPU in the process of processing the instructions, it may collect the input values from this, and it also stores the output results in the memory. Now, the generated output, we need to suppose if the output is an audio file that should be played in the speakers, then the output will be passed to speaker. If the output is a printout, then the output instruction is passed on to the printer device which is connected to your computer. If the output is a monitor, system monitor, then that output will be, we can observe on a monitor. It's like input unit, output unit, memory unit, and central processing unit, control unit, arithmetic logic unit, and registers which can be performed read and write operations. So this is a working flow, a functional flow of a computer among the different number of blocks. And here if you consider this registers, what is the difference between registers and memory? Registers are the small size which can hold small amount of information. It's not like our main memory. It is a main memory. Main memory is used to store the huge volumes of information. The capacity is also large, whereas the register's capacity is small. Used to store a small amount of information. For example, in your classroom, the subject lecturer will carry a register to mark the attendance of the students. In register, what they maintain? Are they going to maintain the lecture notes? No. They are going to just mark the simple information about each and every student on a particular day and a particular hour, whether the student is present or absent. Very small amount of information is maintained in the attendance registers. In the same way, in our computers also we have registers, but the register's purpose is to maintain the small amount of information. Now, what are the different types of registers? There are memory address register, memory buffer register, program counter, instruction register. These are the 4 important registers that are introduced in our CPU. Memory address register will hold the address of a data. Memory buffer register holds the value of a particular variable. And program counter points to the address of the beginning instruction in a program. Address of the instruction. And instruction register holds the instruction which is available at the PC location. So PC will hold the address of the instruction. Address of instruction. Whereas instruction register holds the instruction. Which instruction? The instruction, if you go to this address, you will find an instruction. That instruction is holded by IR. So IR will take the reference of the PC. PC holds the address of an instruction. So if you go to that address, you will find this instruction. So instruction is holded by IR. Address information of the instruction is holded by PC. And PC values gets updated by 1. That means initially the PC register points to the first instruction address, by default it is updated by 1. So automatically it points to the upcoming instructions. Next, the updated by 1. Like that, each time it gets updated by 1. That means it is going to point to the next instruction, second instruction, third instruction, and so on, nth number of instructions. What about address register? Address of a variable. Here we are talking about address of variable. Whereas memory buffer register stores the value. We are going to assign some value of this variable that can be found inside the memory buffer register. Here both ME and PC both the address, but here it is address of instruction. Instruction is nothing but like this, n number of variables are created in a meaningful form, that is called as an instruction. That instruction is located some address, that is different. But here we are talking about a single variable. The variable assigns with some value. That value is holded by MBR, and this variable's address is located in a register that is called MBR. So like this, we can use different number of registers for different purposes. MBR, PC, and IR. The next one is about instruction lifecycle. What is an instruction? So instruction instructs the computer what to do. Suppose I give one example: C is equals to A plus B is an instruction that instructs our computer to perform the addition between A and B and store the result in a variable called C. The instruction life cycle holds different phases: fetch instruction, decode the instruction, decode and calculate the effective address, and fetch operands and execute. These are the four important phases. FI means fetch. Fetch means reading. Fetch instruction. Decode and calculate effective address. Decode and calculate effective address. Fetch operand. Execute instruction. Execute instruction. So fetching the instruction means read the instruction. Decode and calculate the effective address means understand what the instruction is representing. Decode it. So fetching means simply reads the instruction, but it does not understand. It does not bother about what it is representing. Now in the next step, it is bothered about what this instruction is conveying. As the instruction needs, as part of executing the instruction, you need input values and you need to go to some address reference and cache the values. So in that process, we need to calculate the target address and get the values for the instruction. Once the inputs are ready, in this second phase, the inputs are gets ready. Once the inputs are address fields are ready. Once the address fields are ready, then you cache those values. Fetching the operands means cache the input values from the memory. Where these operands can be fetched, in the above step, address values are calculated, where the variables are located or where the instructions are located. Once we go to that address, we can get the values of the operands. Once the operands are ready, then we can start execute the instruction. So these are the major four phases: fetch instruction, decode and calculate the effective address, and fetch the operands, and execute the instruction. So this is one phase, this is one phase, this is one phase. These are the four phases of life cycle of an instruction. That means instruction will instruct our computer what to do, and when the life of the instruction begins, when the life of the instruction ends successfully, the time span between these two phases is called as the life cycle. For example, in our human beings, we have, when we born, we are called as infant. When we are grown, we are called as a childhood. When still we are growing, we can call it as a young age, middle age, old age. It's like that. Based on the stages of our lifestyle, we are named it as infant age, childhood, teenage, middle age, old age. So how they are named it in the same way for instructions also. As when it is born, it's like fetch instruction. When it is getting old, it is called as execute instruction. When it is in PNAs, it is called as calculated ability address. When it is in middle age, it is called as switching operators. Like that, we can just imagine that how we have different life cycle phases. Same way in our computers also, the instructions also having life cycle phases during the lifetime of the instruction. And the next one is stored program concept. So what the storage is very important. How a computer is going to store the applications or the programs. Program is set of instructions that are going to be performed, specifically solving a given job or a given task or a given work. Now, how this program is going to be stored using different set of memories and registers. In memory, we have primary memory, main memory, secondary memory, third memory, or expandable memory. Okay, it's like we have different types of memory components for the storage purpose. As a human being, we cannot remember much information. We cannot keep much information in our brain storage. So we will depend upon our electronic storage only. In the last month, suppose last month on 10th, what are my activities? I can check my activities because I am going to save my activities in a particular file in my computer, so that once I open it, I am able to recollect that on that day I done these are the activities. Similarly, the same job is done by using stored program concepts by introducing the memory unit concepts.